So today we are going to discuss the transfer of circuit impedance parameters. For ease and simplicity of calculation, it is preferable to work in one circuit only. That is, either in the primary or the secondary circuit. So equivalent resistances and reactances are found in order to make the transfer possible. Okay. Now, the secondary resistances and reactances are transferred to the primary side in such a way that the ratio of E2 to E1 is not affected in magnitude or phase. So according to this circuit, let R2 prime be the resistance which must be placed in the primary circuit in order to produce the same drop as produced by what R2 in the secondary. Then we can say that what R2 prime causes a voltage drop in the primary, which is equal to I2 prime R2 what prime, right? So, and the ratio of what I2 prime and that of what I2 R2, which is the voltage drop in the secondary, must be the same as the turns ratio is what N1 on what N2, which is also known as what the V1 over V2, which is also the same as what our E1 on what E2. So it means that what the ratio of these two, this and this, must be equal to what we have here, which is the same as what I2 prime R2 prime all on what I2 R2, because this is the voltage drop within the primary and this is the voltage drop in the secondary, and this is the same as the turns ratio, and the turns ratio is the reciprocal of what the transformation ratio, so it's 1 on what K. Okay, so if that is the case, then we can see that what I2 prime R2 prime all on what I2 R2 is the same as what 1 on K squared. So let's make R2 prime the subject from this equation, since that is our focus. So we multiply this side and that of this side and make R2 the subject. So we can say that what R2 prime is equal to I2 R2 I2 R2 all on what I2 prime K. Okay, so we already have the K there. Now from this equation we know that what I1 or over what I2 is equal to K, right? So if you have the reciprocal of it, which is I2 over I2 prime, I2 prime is more or less than I1, then we can see that what the results will give us 1 on what K. Okay, so we can see that what R2 prime is equal to R2 all on what K multiplied by 1 on K. We already have this K here, so the results will give us R2 all on what K squared. Okay, so anytime we are doing any referral within the system, we are saying that what if we are referring the secondary voltage into the primary, we just need, so if we are referring the secondary voltage into the primary, we just have to take the same R2 and divide by what K squared. Similarly, if you are referring the primary to the secondary, which is what if you are referring the primary to the secondary, which of course is the same as what I1 prime, then it's going to give us what R1 K squared. So this is different from what we derived earlier. Okay, so let's move on with it. Now let's find the equivalent resistance as we refer to the primary. So from my circuit, so let's find the equivalent resistance as referred to the primary, which of course is the same as what R01. Okay, R01. Okay. Now, when we say equivalent resistance, that means we are talking about the total resistance within the what? Within a particular one circuit. And these circuits are always what? Represented in what? Series form, right? So if you are looking for the equivalent resistance, that means that we are looking for the resistance at that particular end, and then we sum all since they are in series. So if you are looking for the resistance, I'll refer to the primary, which is the total resistance. then it will be the same as the R1 which is already there, right? So that will give us R1 plus what? The referrer, which is the secondary that we have referred to the primary, which is the same as what? The R2 what? Prime. And we know the value for R2 prime, so we can say that what? R01 is equal to what? R1 plus R2 divided by what? K squared. So similarly, let's look at what? X01, which is the equivalent reactances. The equivalent reactances as referred to the what? To the what? To the primary. And that will also be the same as what? The primary reactance itself, which is what? X1 plus what? X2 what? Prime. Then it means that what? X1 it will be the same as X1 plus X2 all on what? K squared. Okay. Now let's do our referral, or let's find the what? The total impedance within the what? Within the primary as referred to the primary. So impedance referred to the primary will be Z01, which is the same as the root of, right? R01 what? Squared plus what? X01 squared. Because we are is impedance, we are going to consider the resistances and the reactances. And then we know that the impedance triangle, which is in this form, where we have the what? The reactances this way, and we have the resistances, okay? So the impedance is what we have here. So we are just taking the Pythagoras form of what we have here, right? Okay. So now let's move on to the what? The referrer. Assuming the referrer is being done at the what? At the secondary section. That means we are going to refer the primary. In that case, the equivalent what? Resistance as referred to the what? To the secondary will be the same as the R2 itself, because that was going to be there, plus what? R what? 1 prime. And that will give us R2 plus what? R1 K1 squared. You realize that it has changed, right? Similarly, if you have what? X02, that will be the same as X1. X2, sorry. That will be the same as X2 plus what? X what? 1 prime, which of course we know that X1 prime is the same as what? X1 K squared. Okay. So let's move further and then establish more points here. Then we can also look at what? Our impedances within the system. So we can have the equivalent impedance as refers to the second, which is what? Z02. And that is always going to be what? The root of what? The root of what? R02 squared plus what? X02 what? All squared. And that is the end of the road for us. So if you have these formulas in mind, you'll be able to undo your referral, which makes computation more easier. And then let's also look at what? The power within the system, right? So we are saying that assuming we are looking for what? The copper loss or the core loss within the primary. Now the core loss is as a result of the resistances within the system, not the reactances. So assuming we want to find the core loss in the system, the entire system, then we are considering the what? The copper loss in the primary and that of the secondary. So the copper loss in the primary, so we can look at the individual resistances. So we can find I1 squared what? I1 alone in the primary plus what? I1 2 squared what? R2, and that will give us the copper loss. Now we can also look at it this way. That's what we are going to consider it in the primary times the what? The equivalent what? Resistances as referred to the primary, which is what? R0 what? 1. If we consider it this way, then we have factored what? The two resistances, that is the resistance in the primary and that of the secondary, because this equivalent involve that of the primary and the secondary, right? So realize that what? This one even tell us that what? Doing the referral makes computation more easier, just like the one we have here. Similarly, we can find the copper loss as what? If assuming we are doing the referral within the what? The secondary. That will give us what? I2 prime R0 what? 2. You get it? So this is another way of doing it, and you get the same results as what? Taking the individual ones and doing it. Thank you very much, and then we are going to meet in our next lesson of what? Transformer analysis. Bye.